Okay, we finished up, and I've uploaded the first part of this lab in-class lab up to YouTube already. This is the second part of the lab, so we finished up the part about the 7474 or the 74LS74. It's a positive edge triggered D-latch. So what we say about with a reset and a clear, I'm sorry, a set or preset and a clear and a reset or reset. What we say about this on the synchronous inputs, we say the Q output follows the D input on the rising edge of the clock. Now these are asynchronous inputs, set and reset. And we always also look that they could be called preset and clear. These are asynchronous, which means they are not untimed. They are not timed with the clock. So if the set goes low, then Q goes high. If the reset goes low, then Q. If the reset goes low, then Q goes low. And of course, not Q should always be opposite unless we bring both the set and reset low at the same time. And we learned that that would cause both the Q and the not Q to go low at would go high at the same time, which we refer to as an ambiguous state. And there's no guarantee how we would come out of that situation. So what we're going to do now is we're going to move over to the D-type, bistable latch. So this is a 74LS75, and it's instead of being a 14-pin dip, it is a 16-bit dip. And so what we have is this is the data sheet on the 7475. It's also got the 7477 in here, but we're in with 7475. Now the 5400 series is what we call military grade. It has wider specifications on it. We're dealing with what we call the commercial grade, which is 7475 or 74LS75. And this is the pin out of the 74LS or 7475. There's 4 latches inside this 16-pin dip. Well, if you think about it, 4 latches. Each latch requires 3 pins, not including power, just the latch itself. But we know that power, and this is one thing you have to notice. So you notice, and I told y'all this, is don't always assume that your power pin is going to be the upper, the VCC pin is going to be the upper pin on the right, looking at it from the top. And then your common pin is going to be the lower pin on the left, because here's one right here where your VCC is over here on the left, and it's pin 5, and then your common pin is over here on pin 12. So if you hook this thing up wrong, you could cause problems. There's each latch or each flip-flop, each latch requires 3 pins. We have a D input. We have a Q and a not Q output. And then the fourth thing that we have on this one is we have a select pin. This is not a clear. This is not a. This is an enable. We've already looked at enables back in your basic labs, where we could use an AND gate as enable, or an OR gate as enable, or NAND or NOR by using one of our pins to either let the signals pass through or not pass through. So this is the enable pins right here, and we'll look at these in a minute. So that means and there's 4 of these things in there, so each one of these latches would have 4 pins. Now notice this does not have a preset, and it does not have a clear. That means each latch would require 4 pins, right? There's 4 of them in here, and that means that would eat up 16 pins. Well, but we've only got 14 pins to work with, because we lose 1 pin for the VCC pin, and we use 1 pin for the common. So what they do is they've allowed 2 latches at a time to share the same enable. So latch 1 and 2 is used by pin 13, and then latch pin 4 is used to enable latch 3 and latch 4. So here's latch 1. This is the one we're going to be using. So what you need to do is go back to the lab and then do your pin out. You need to go ahead and pause this lecture and do your pin out, okay? And then what we'll do is we're going to use latch number 1. Go ahead and pause the lecture now. Okay. Okay, now what we're going to do now is we're going to use latch number 1. So latch number 1 over on the data sheet will be, here's the 1D on pin 2. Here's the 1Q on pin 16. Here's the 1Q not, or not Q on pin 1. And our enable that we're going to be using is pin 13. So go ahead and go over here on your diagram and then fill in, oops, wrong one, Bridge. Fill in this right here. So you can go ahead and pause the lecture and write this in. And like I told you on part 1, I'm doing the wiring of the circuit. I'm doing this. I'm doing the truth table. So what you're going to be graded on, of course, is doing all your pin outs, right? Put your pin outs, put your pin numbers out here on the outside. And then also, now the switches that I'm using is for the D. So for the D, which is this guy right here, I'm using 1. And for the enable, I'm using 2. Switch 2. So this is what I'll give you, okay? Oops. So for the D, I'm using switch 1. And then for the enable, I like this. So this is on our data sheet. This is what they're calling C, right? And so we're using 1C, right? Which is also stacked on top of I think 3C. And then on this one, I'm using switch 0. Okay. And what we're going to do is so here's my circuit. Okay, so that's the shadow of the camera here, guys. We can't do much about that. Okay, so here's my 7475. Okay, here's my 2 switches. So I'm using switch 1 as the D. I'm using switch 0 as the enable. Okay, notice here's my power coming in. I swapped the red, so here's the red on this side. So this is my plus on this side, and here's my black because of the way the pins on the 7475 are laid out. And here's my common pin. Okay. So what we're going to say about this one, so we have D, right? Then we have E, which the data sheets are calling C. Right? And then over here we got Q. And then over here we got not Q. Now this is standard practice, guys. Let me redo this again. Standard practice is to draw your inputs on the left, and then we put our outputs on the right. So we have Q and we have not Q. Okay. And then, of course, on this one, notice we don't have the triangle because this is not an edge-triggered latch. This is a level-triggered latch. Level trigger means as long as E is, and there's no bubble, so that means E is high active. So enable equals a high. Okay. And of course, latched equals a low on the input. And we're looking at this at the data sheet. Now what we say about this guy is that we say Q, which is the output, follows D when E is high. And then of course, when E is low, we're latched. Okay, so we'll look at the data sheets now. So here's our bistable latch, okay, and here's our data over here. So notice the truth table is a lot smaller because we've left out, this guy here does not have a clear and it does not have a reset. So it says here when D is low and C, which the other one is called an enable, and this is just something you're going to have to get used to because different manufacturers call this different things. It says that C is high, then Q goes low. So what happened is Q followed D. And of course, not Q is going to be the opposite. It says over here, if D is high and C is high, then D goes low. I mean, Q goes low. So Q followed D when E is high. Here, if C or enable goes low, D don't care, and Q output and not Q is going to be equal to each other. So what this is telling us is this is the way they tell us a latch is latched. Okay, so that's true. Then what we're going to do, now hopefully we understand the truth table. So what we're going to do is go back to the lab. Okay. And what we're going to do is we're going to go through the truth table, but I'm going to show you a little more. I'm going to have to take this off. We should already have our pin out up here, right? We're using latch number 1, right? And of course, on this, you don't draw the power, but remember the power has to be connected for these devices to work. So I'm going to go ahead and go back to my camera, and we can fill in the data. We can fill in the truth table. Okay. So here's the data right now. I'm using light 7 for Q, just like the 7474, and I'm using light 6 or LED 6 for my not Q output. So when I look at my truth table, it says enable is high, D is low. Okay, so there's enable and high, D is low, and notice Q went low, of course not Q is high. Then the next thing is we leave enable high, and I switch D to a high, and notice Q goes high, not Q goes low. Okay, so right now, Q is following D. So if my switch is high, I get a high out. If my switch is low, I get a low out of Q. High, low, high, low, high, low, high, low, high, low. And what I'm going to do now is I'm going to come over here and I'm going to bring my latch low. And whatever happened to be on the Q input at the time, whatever happened to be on the D input at the time is latched into the latch. Okay, so I'm over here switching D like crazy. Okay, now I'm going to go back high, and notice Q follows D, and I'm going to try to latch it on a low. Now it's latched on a low. So as long as this guy right here is high, as long as the enable is high, Q will follow D. And when this goes low, it latches whatever happens to be on the D input at that time. So this guy, 7475, does not have a preset. It does not have a clear. It is edge triggered. It is edge triggered. I'm sorry. It is level triggered. Woo! Almost screwed that one up. It's level triggered. So that what that means is when E, as long as E is high, then Q follows. As long as E is high, then Q follows D. So there's D is up, Q is 1, here D is down. And if we want to latch it, then we flip that, and whatever happens to be on the D input at that instant in time will be latched through to the output. Okay, so that's the D type 74LS75, the level triggered latch. They call it a bistable latch, which means it's going to follow D, and then when we bring E low, whatever happens to be on the input, the D input at that instant in time will be latched to the Q output, and then of course not Q would always be opposite. So this is the second part of the lab lecture. This deals with the 7475, and this is on page 116. So what I'm going to do is I'm going to go ahead and upload this.